Yeah,
I don't
this,
understand.
but what I find it so interesting is that this subject riles, a certain group of people up so much. And you know what? If it's true science, then whatever's true at the end of the day will become true. So what are you afraid of? If you firmly believe that it's a globe, then what are you afraid of? Why fight it?
Yeah, absolutely.
Do you think it's worthwhile to fight someone that's distributing falsehoods?
Do you think I'm distributing falsehoods?
I think all the flat earthers are distributing falsehoods.
Am I a flat earther?
I'd say you're more of a flat earther than a non-flat earther. Right?
Always with the
I mean,
labeling. No.
you do put on hangouts where you basically give an audience to flat
Sure, I'll
earthers to
talk about
distribute
it.
their info.
Yeah, I'll talk about it.
And you don't try to refute or question any of it.
No, I do quite a bit, and my arguments have been quite changed since me coming out here. I've learned so much, and I've corrected other people's arguments when they're bad. That I don't understand what could possibly be bad about asking this question. If it is a sphere at the end of the day, then you have nothing to fucking worry about, do you?
So would you say that let's say that I don't believe in the germ theory of disease, and so I go on hangouts and I tell people, look, you don't need to stay away from sick people, or wear
False equivalency.
how is that a false equivalence?
Well, germ
Because
theory is an actual scientific theory, epistemology. That's why.
Oh my God. Hey,
Yeah.
John.
welcome to the show, motherfucker. Oh, not you, John. Hey, John.
Hey, gentlemen, how's it going?
It's good, man. Now.
Thought I'd just pop in. So,
Yes.
epistemology, what's your scientific evidence of your spinning ball religion? Go.
I'm not even going to acknowledge that, John. We've had this discussion for how many back and forths on the
Yours is still
comment section.
incoherent.
By the way, you kind of gave up in that comment section.
Scientific evidence, sir.
I don't see you ever responding there. So
Scientific evidence, sir, to your spinning ball religion. Please. Number one. Let's hear the hypothesis.
we've been over all this, John. We've been over all this.
Yeah, that doesn't mean that you're
John,
not still wrong.
why don't we go over your credentials about your ability to understand
Yeah, everyone
scientific
wants
evidence?
to go over my credentials.
Let's go over your credentials and see what you know. Okay.
Well, we can judge that by the content of what I'm saying, can't we?
Yeah, and we did that in the comments section.
Oh, we did that. Yeah, we did. Hey, did
And
you get in touch with Professor Shankar? Did he tighten your shot group? You're a pretender.
He never responded to my email, but all you had to do was read his document, and you could see that you totally took it out of context.
Sir, you wouldn't know what real science was.
So let's go over that. Let's go over his lecture.
Yeah, let's go over it, pretender.
Okay. So he says in there that all of Newton's stuff works on the scale that we all inhabit.
Really?
And you said that it doesn't work. Yeah, absolutely. He said that. Yeah, let's go back and look at that.
Go ahead, pull up your screen share. Let's go look at the document.
Let me find it here. Hold on.
Sure.
Did I miss something?
I like science.
No, they're getting their weapons honed, I think.
No. All right.
They're grabbing the document or something.
It was a quick engagement.
Yeah, and for a minute I thought someone got sniped. I'm like, what happened?
No, we're still good. We're waiting him to pull up the document.
I do wonder what the scientific hypothesis of the round Earth looks like, though.
There isn't one. That's why there isn't.
Oh, yeah.
Go to the part where it says that is the end of Newtonian physics, please. That's all right. I'll point you to it. And then we'll discuss the reasons why. Am I echoing?
No, you're good, brother.
Yeah, and no, I don't know, man. I think it'd be nice to at least get to the point where it's cool for whoever to believe whatever they want, and
not try to dissuade people from looking into specific topics.
Well, he said that there's evidence. So I want scientific evidence. Scientific evidence is brought to us by the scientific method. That means I want to see the hypothesis. And more importantly, epistemology, can you tell me what the ultimate goal of every scientific inquiry is, please? What is the ultimate goal? And if you can't answer that, why are you even in this discussion?
Oh, he's just here to try to assert his belief system over somebody else's. I already made Timmy rage quit. Did you have a good day, John?
Yeah, I was winding down. In fact, I was just going to shut the computer off, and I was looking at something, and then I seen Spectacles live, and I said, "Oh, I wonder what's going on."
Yeah, Timmy and I was having a cage match, but he ran off again. I seem to have that effect on him. As soon as I make some points that are...
Yeah, I missed that.
Yeah. And then good old epistemology over here, you heard him. He thinks that this question is not worth asking, and that it should
Yeah, I already
be
dealt with him on the other forum. Why don't we just go ahead and pull up the forum that we were commenting on, and we'll go through that. We don't have to put up with his
he might have like ran away, actually.
imagined stories.
John, I think he might have made him run away.
No, let's go ahead and pull that stuff up. Hey, what's up, upside down head?
Yo, what up? What up?
What's up, sir? I haven't talked to you in a while. Did you watch the last presentation, sir?
Yeah, I was in the chat trolling.
Oh, I didn't. I don't pull up the chat, man. Especially with that presentation, it was a little bit time consuming.
Yeah, pretty taxing. You got to go over quite a bit.
How do you like that presentation, sir?
It was pretty good. It was. I thought it was well done.
Did you think I went a little bit overboard?
A little bit, but it's all right.
Hey, I had to, man. I was trying, like I told Cathexis, I had to try to establish the foundation there. So,
Right, you're getting into some pretty specific things.
Yeah, yeah. You know what? Afterwards, I said to myself, I just should have stopped at the bike.
Stopped at the bike. Now, I think going over the flagellum is quite important. But see, you're so far down the rabbit hole, John, with all of this. Like you've had to, you're like arguing against like PhD level people on forums and whatnot. That you have like the three answers to their answer to the flagellum.
No, Cathexis, listen. That presentation was directly pointed to Dr. Kenneth Miller. Hold on, epistemology. That presentation on the irreducible complexity was directed and made directly towards Kenneth Miller. He's the professor of cellular and molecular biology at Brown University.
Did he respond?
See, he was the one that allegedly, purportedly debunked Behe, right?
Uh-huh. Oh, okay.
So see, people don't bring up irreducible complexity like that. They just say Professor Behe's an idiot, and it's debunked.
Yeah.
That presentation's not for those people. That was directly I've been trying to chase him down for 6 years, 7 years now. He ain't gonna answer me. I had a bunch of his cronies. Email him that presentation. I know they did.
Yeah. If he took the time, though.
There's no way. You listen to it. There's no way out.
Mm-mm.
So go ahead, epistemology.
Okay, it took me a little bit to find go through the freaking comment section to find my notes here that in our little discussion on here. But if we look at the transcript from which you quoted from regarding,
Sure.
Newtonian physics is dead, right? He is referring to things at the quantum scale because.
No.
What do you
No,
mean?
that's not what he
Hold on,
said.
let me read a quote. Let me read a quote from him, okay?
Go ahead.
Let me read a quote from him. The real question is, how do these very same laws, when applied to big things, by big things I mean things you see in daily life, give the impression that the world is Newtonian,
That's correct.
right?
That's correct.
So he's attesting that Newtonian physics is what we see on the large scale. And further, if we go above that, hold on. If we go above that, we go above that.
You're misunderstanding it.
You're going to let me finish my point? Are you going to let me finish my point?
Sir, you're
And then I'll
already
let you talk.
clobbered your own
Let me finish
argument.
my point. Let me finish my point, and then
Go ahead.
Okay. Further, above that, he says, let me bring up the machine gun reference, okay? Because that very clearly exemplifies the fact that things at the quantum level is not how things are at our scale.
You just contradicted yourself with what you just said.
Wait, how did I contradict myself?
Read what you just read. Where Newtonian physics only gives the impression the world is Newtonian. You just contradicted yourself.
No.
You
all of the Newtonian rules apply at our scale, and he even says that in the lecture with regards to machine guns. I gave an example. Here it is directly from the quote, okay? I gave an example with machine guns. This is a machine gun. This is a concrete wall with 2 holes in it, and there's a target here.
Yeah.
And then you see how many are coming through this and how many are coming through that. Then you go there and you wait, and both are open. Somehow nothing comes. With the second hole in the wall, you are safe. With 1 hole in the wall, you are not safe. The next sentence, this can never happen with bullets. In other words, if this was a real machine gun with bullets, that's not how it works in reality.
No, you're misunderstanding it.
No. That's exactly what he's saying. He's saying at our scale, you would not be safe with 2 holes in the wall the way you would at the quantum scale.
Scroll down in the document, because you already contradicted yourself. Now scroll down in the document and read this. That is the end of Newtonian physics.
He's talking about when it comes to describing things at the quantum level.
That is the end of Newtonian physics.
Newtonian physics perfectly describes things at our scale. And he even says that further down, right? Let's find another quote that exemplifies what I'm saying.
We don't. All we need is the first one you said. Let me repeat it. The laws of physics are always quantum mechanical laws. You don't have separate laws.
So that means we should see.
Would you please?
So that would mean that with the.
Could you stop him?
Okay, go
Let
ahead.
him finish epistemology. I just want to hear the quote again.
Hey, go ahead, John.
You already stated that he said, and then I'm going to show you. The laws of physics are always quantum mechanical laws. You don't have now separate laws for big and small things. The real question is, how do these very same laws, when applied to big things, by big things I mean the things you see in daily life, give the impression that the world is Newtonian? If I was giving you the impression that I'm Superman, am I Superman? That's it. You're finished. Next subject.
Okay, so then that would mean then, John, that then if we do put 2 holes in the wall and we shoot a machine gun and you're standing on the other side, you don't have to worry about it because the bullets will create an interference pattern with themselves, right? Because if you're saying that Newtonian physics doesn't describe what things happen, and that we only have to use quantum physics, if we only have to use interference patterns, then we don't have to worry about it.
Sir,
that's what he said.
The only reason that we can't see it is because our eyes are not attenuated enough to see it. If you look under the hood, quantum mechanics rules. That's why he said that is the end of Newtonian physics. Roll down in the document and pull that quote out.
Yes, but what you're not understanding, though, would you agree that when he says it gives the impression that the world is Newtonian means that Newtonian rules apply at the large scale?
No, it's just
No?
giving the impression.
So that would mean then that that the Newtonian rules of physics don't actually apply. That those aren't actually accurate. When you make experiments.
That's right. They're not. Yeah. And I got an
So
experiment.
you make experiments. So that means you shoot a machine gun through 2 holes. You expect an interference pattern because the Newtonian rules don't apply.
I just told you, because our observation, our eyes are not attenuated enough.
Wait, but do you get shot or do you not get shot?
We cannot see the quantum mechanical effects. That doesn't mean they're not there. Do you understand that? That's why he said there's no other laws besides quantum mechanical laws. You don't have separate laws for big and small things. Go ahead and read over that quote again. It's very clear. Now, where's your scientific evidence for your spinning ball religion? Hello?
Hold on, we're not done with this point yet. I'm trying to find this other quote from him that I used in my comments with you. No. I want you to look at the whole document. You got to take the whole document for its whole.
I've already studied it years ago. I have all these right here in front of me.
So why does he say in that same document, he says, in the macroscopic world, you will not see this interference?
Because I just told you our eyes are not attenuated enough. Keep going.
Oh, okay. But wait a minute. But do you get shot or do you not get shot with 2 holes in the wall and bullets passing through it? Tell me, which one is it? Because if we can't see it, it's okay. It doesn't matter. I mean, you can't see a bullet when it's going to hit you, right? But we do see the effects of it, right? You don't see the bullets flying when you get hit, right?
What
but
is
you do
the
see
Newtonian
the effect of it.
prediction, sir?
The Newtonian prediction with 2 holes is that bullets will come through both holes, and so you're not safe behind either hole.
Listen to what I'm telling you right here. I got the experiment. We have a double slit experiment with a Newtonian particle, an electron. That is a Newtonian particle, correct?
Is a bullet not? What about a bullet? Is a bullet a Newtonian particle?
Can we stick with my argument here?
Okay, let's go ahead. Let's follow it through its end.
So we have a double slit experiment with a Newtonian particle. It's an electron. Do you agree that an electron is a Newtonian particle?
I don't know if you would necessarily call. No, you wouldn't call that a Newtonian particle because.
Well, your professor in that document calls it a Newtonian particle.
Okay, I'm not an expert on quantum physics here, so.
That's obvious.
But Newton did not do experiments with electrons. Okay.
And so
firing individual electrons, right? Newton was looking at large objects that he could for his era.
And so what?
Okay, well, go ahead. Let's take this out to its end. Okay, so go ahead. So we fire electrons, which you want to call Newtonian particles. Fine, we'll call them Newtonian particles.
No, I'm not calling them. That's what they are.
You know, they're little tiny bits of matter. Okay, so go ahead. Okay, we fire them.
Your document in there says the same thing. An electron is a Newtonian particle. We close one slit and fire a bevy of electrons, and we get 10 hits at point A. We close that slit and open up another slit, and we fire a bevy of electrons, and we get.
He says maybe if it's an ordinary particle like a Newtonian particle. He doesn't say an electron is a Newtonian particle. He says maybe if it's an ordinary particle like a Newtonian particle.
No, he doesn't. You need to go back to quantum.
I'm quoting you directly from it. Tell me where he says an electron is. Show me the sentence that says an electron is a Newtonian particle.
You have to go to Quantum Mechanics Experiments 1, Wave-Particle Duality from Professor Shankar.
Okay, just link me in the side chat a quote where he says an electron is a Newtonian particle.
Sir,
please link me. You just said that's what he said. Show me that he said it.
Even that I'm explaining this to you is a tell that you are clueless.
Wait. No, John, you just made a claim. I want you to prove the claim. That's what you're always asking me to do. You made a
Quantum
claim. I'm
mechanics
telling you in the document that you quoted, he does not say that. I
Quantum
just
mechanics
read it to you verbatim.
Quantum
That's
mechanics 1. Quantum mechanics 1, sir. Here, I'll put it in the side chat for you. Hold on 1 second. It's quantum mechanics 1.
This is a pretty good tactic, John, of his to try to avoid that
No, that's all right.
scientific.
That's all right. Let me put it in here. Go on. I don't know if it'll.
Because basically what you're saying, John, you're saying that the bullets will behave just like an electron will.
I'm not talking about bullets. No, I'm not. No, I didn't say that.
Oh, so that's not. So the bullets aren't going to behave like electrons.
I'm saying a Newtonian particle.
Are the bullets going to behave like electrons, or are the bullets not going to behave like electrons?
We don't have the size of the experiment to show it. We cannot see it. That doesn't mean it's not happening.
If we can't see it, though, can we see the effects of it?
No.
Oh, we can't.
We can't, because our eyes aren't attenuated enough.
So if we're shooting,
if you keep going in the document, he tells you that. If
we're shooting a machine gun through 2 holes in a steel plate, are we going to see an interference pattern behind those 2 holes, or are we not?
Sir, you have to get the slit width appropriate to the size of what your experiment is first. That's where you're going off the rails. We can't see it. That's what I'm trying to tell you. That's what he tells you.
I can't see radio waves, but I can see. We can't see radio waves, but I can see the evidence of radio waves, right? Like when I cook my food in a microwave, that's a radio wave, but I can't see.
What are you talking about radio waves for?
No. Because you're saying we can't see it, and we can't determine what the effect is, right? But I can't see a radio wave, but I can see it, the effect of it when it cooks my food in the microwave, right?
What do radio waves have to do with my Newtonian
Because it's something that you can't see, but you can see through the effects, and you can inference what's going on.
Yeah. Well, we can't see the electron,
but we can inference. Right? We can inference what they're doing based on their interaction, right? Which is the whole way this double slit experiment is conducted, right? Because we're going to see the laser create an interference pattern against the wall with the 2 slits.
That depends. What does that depend on?
What do you mean? What does that depend on?
What does the interference pattern depend on?
The interference pattern depends on the electrons having the capability to interface with one another, right?
No. Whoa. Why? How do you get an interference pattern from Newtonian particle electrons? They're particles.
No. You still haven't proved to me that it's called the Newtonian particle anywhere.
I put the link in here. I don't have the time. I'm sorry. You're going to have to go through that video right there. It's quantum mechanics 1. The key experiments in wave particle duality. And you can go to the 2-minute mark when he says this. All right, so today we're going to shoot down Newtonian mechanics. Then you can go to the 3:18-minute mark of that same video and listen to this. First, I want to tell you what goes wrong with Newtonian mechanics. The double slit experiment is a problem. That's what puts the nail in the coffin for Newtonian physics. What does nail in the coffin mean, sir? Please explain to me what shoot down.
The purpose of this lecture is to explain that when it comes to describing the quantum realm, you cannot apply Newtonian physics.
That's not what he said.
That is essentially the point of the lecture.
No, it's not, because he just told you all the physical laws are quantum mechanical laws. He already told you that. You read it.
That still doesn't change.
Now back to your what is the deciding factor when you fire an electrons through a double slit experiment? What's the deciding factor whether you get an interference pattern or a particle pattern? You're in a quantum mechanics.
Hold on. You know what? I'm reading.
You don't
Hold on, John. Let's go back to this. Electron is Newtonian particle. Actually, if you read,
yeah.
I'm looking at chapter 5, particle wave duality of matter. Here, let me post the transcript link on the side here. He actually is basically disproving that electrons. The whole point is he's not saying that electrons are Newtonian particles. He's disproving that electrons are Newtonian particles.
There are Newtonian particles. Electrons.
He says no. Because he says this is surprise. Hold on. He says this is the surprising thing, because if an electron is a Newtonian particle and you used to go like that through hole 1 and you used to go like that through hole 2, if you open the 2 holes and 2 slits, you've got the sum of the 2 numbers.
That's
you cannot escape that, because Newtonian mechanics, an electron either goes through slit 1 or slit 3.
Right.
And therefore the number coming here is simply the sum of the ones that went here and the ones that went there.
That's it. That's the end of Newtonian physics.
No. But that's what he's saying is that electrons don't behave like Newtonian particles. That's the whole point of that paragraph.
No, they are Newtonian particles.
Where does he say an electron is a Newtonian particle? Show me the quote.
He says it in that link I just gave you.
Let's look. Let's find the quote. Hold on.
You ain't gonna find the quote. It's a video. There's no transcript.
Where's the at 1 minute marker, so I don't have to go through the whole video right now, so we don't.
Yeah,
so
where he says nail in the coffin for Newtonian physics. It's at 318.
Wait a minute, but I think that this is the transcript that I'm reading from, isn't it? Isn't it the same thing that he's?
No.
You're
on the wrong video.
Transcript of that lecture?
No, you're on the wrong video. You're on quantum mechanics 2. Go to quantum mechanics 1.
Okay, so I have a question here. So you're saying that what would we have to do to make bullets give us an interference pattern? What would we have to do? What's our limitation here? What would we have to do to make bullets give us an interference pattern?
You'd have to make the experiment and the slit width compared to the wavelength of the bullets comparable.
Oh, what's the wavelength of the bullet?
I don't know right now. I'm not going to figure it out either, because it has absolutely nothing to do with this argument.
But he basically said that things behave Newtonian on our scale.
It was an analogy, sir.
He said things behave Newtonian at our scale, and he said that in the real world, if you have a machine gun behind 2 holes, you're going to get shot.
It was an analogy, and then it disproved Newtonian mechanics, like I just said. And he said it. You quoted it. It was the initial quote that you brought up. The laws of physics are always quantum mechanical laws. You don't have separate laws for big and small things. Do you get that?
Hold on. But in that same exact sentence, let's read the whole sentence, Sean. Let's read the whole sentence, okay? The laws of physics are always quantum mechanical laws, but when you apply it to an elephant, you get one kind of answer. When you apply it to an electron, you get another kind of answer.
That's correct.
How do these very same laws, when applied to big things, by big things I mean things you see in daily life, give the impression that the world is Newtonian?
There you go. Thank you very much. You're finished.
What that means is that on the large scale, things are not behaving quantum. There may be quantum laws. No. What he's saying is there's quantum laws operating in the background.
No, he's not saying that, sir.
That ultimately they're quantum mechanical laws that are operating the whole system.
I'm giving you the impression that I'm Superman.
But John, even though there's quantum mechanical laws working behind the whole system, when we're at our scale, those quantum mechanical laws behave differently than they do when you do the double slit experiment.
That I'm Superman. Am I Superman? If I'm giving you the impression that I'm Superman, am I Superman?
We're at an impasse here, John, because you and I are reading the same. We're reading the same transcript. We're reading the same transcript. We're quoting from it, and you somehow see something different between the two of them.
You don't even know what the difference is between a particle pattern and an interference pattern is. And you're discussing quantum mechanics. I mean, are you kidding me? You got to give me a break here. Why are you in this discussion? Somebody help me, please tell me why is
Oh,
he
I think that you're totally misrepresenting his position.
How am I misrepresenting his position, sir?
Because you're basically saying that Newtonian physics doesn't apply. And
The
he's
laws
saying
of physics
that
are
on our
always
scale, the
quantum
world
mechanical
behaves
laws.
Newtonian. He's saying in that very lecture, the world behaves Newtonian at the R scale,
No.
at the scale of an
No.
elephant. Why does he say
gives
that?
the impression
Gives the impression means that
that the
behaves
world
in
is
a way.
Newtonian.
It behaves in a way that makes you believe that this is true.
But when you look under the hood,
Do an experiment, and the
not
result you get, it gives you the impression the world is Newtonian. Because at our scale, every experiment shows that Newtonian physics holds up.
No. It's given the
It
impression.
doesn't. Okay,
That's
so
right.
please
You
explain
just
to me,
said the
how does it
experiment.
give the impression if the experiment doesn't behave Newtonian, how does it give the impression that it's Newtonian?
The experiment doesn't give the impression that's Newtonian.
Then why does he say it gives you the impression? You just said it gives you the impression that it's Newtonian. So if you do an experiment and it gives you the impression it's Newtonian, then tell me how is it not Newtonian?
He said, the real question is, how do these very same laws, when applied to big things, by big things I mean you see in daily life, give the impression the world is Newtonian, not the electron?
Right, exactly. Which means if you do an experiment at our scale, you're going to get an answer that's in line with Newtonian.
What experiment?
That's why he says it gives.
What experiment?
Like shooting a machine gun behind two holes. That type of experiment.
Have you performed that experiment?
I haven't performed that experiment, but it doesn't take a genius to figure out that bullets don't interfere with one another.
Because no one has, right? It's giving the impression the world is Newtonian. Like I said, if I'm giving you the impression that I'm Superman, am I Superman? No, I'm not Superman.
Let's put it this way. So in your example of the Superman, that would mean that you'd be able to fly, you'd be able to lift, you'd be able to lift virtually anything. You could shoot laser beams out of your eyes. Yeah, you would give the impression that you're Superman. Maybe you're not actually Superman, but
that's right.
Everything about your capabilities are as if you're Superman.
That's right. When you look underneath the hood, it's not Newtonian. That's what he's saying.
Right. I agree with you there, John, except for the part that I don't agree with you on is the fact that you're ready to throw Newtonian physics as if it doesn't work, but it does.
I'm telling you,
and nothing in his lecture, nothing in his lecture says that Newtonian physics doesn't work at our scale. He said when you try to apply Newtonian physics to the quantum, when you try to apply Newtonian physics to the quantum realm.
Shoot down Newtonian mechanics, nail in the coffin for Newtonian physics. That is the end of Newtonian physics. I don't know, sir.
It sucks that he never replied to my email. But
of course he didn't, because you don't know the basics of just how an electron, how you get an interference pattern, whether a particle pattern. You don't know that. That's basic quantum mechanics. You don't know.
What do you mean? What do you mean I don't know? Well, ask me a question and let's see if I know. Ask me a question.
I did. How many times did I ask you this?
Go ahead and ask me the question again. I missed it.
What is the difference between getting a particle pattern? We're shooting electrons at a double slit.
Sure.
What is the difference between getting a particle pattern and a wave pattern on the back wall?
The difference is whether we put up a detector to determine the path, the which way path.
Just a detector?
What do you mean, just a detector? If we register the which way path information.
Ah, there you go. That's what I was waiting for. The which path information, not the detector. The knowledge of the which path information. Because I told you that on our little rambling on the forum, right?
I don't recall.
Yeah, it's on there. That's right, the which path information. That's right. So it takes a knower to collapse the wave function.
No, not necessarily a knower. No, I don't think it has to do with consciousness.
How do we know? Who knows the which path? How does something know the which path information?
As long as it's registered somewhere, the which path information will. But it doesn't have to require a human. The test can run without a human watching it.
Oh, really?
It could be recorded for
What
100 years.
non-human?
The data could be
What
recorded for
detector-
100 years
what
from
detector
now.
is made that's non-human?
What do you mean? It's not a human being
What-
that's actually doing the detection.
What detector? Yeah, but who makes the detector? The detector's only a surrogate.
Okay, well, I don't want to go down this road with the
Why not?
the woo the woo.
This is a good
Well,
road.
it's not relevant to our conversation right
It's
now.
not woo physics. How's it woo?
No, it's woo to say that it requires a human being to.
It requires a knower. Who knows? An intelligent agent knows, right? You saying it's woo?
No, it's woo because all that you're saying, all that you're saying is that you require a knower and intelligence in order to create the interference pattern, and I don't think you're going to find.
No, not to create the interference pattern, to collapse the interference
Collapse
pattern.
the interference pattern, sure.
It violates his religion.
Yeah.
Oh my God.
So if you don't believe me when I tell you that the path information or knowledge is the key, then we can just go to the proceedings of the National Academy of Sciences in 2013 from Zhao Sung Ma, the quantum erasure with the causally disconnected choice. The presence of path of information anywhere in the universe is sufficient to prohibit any possibility of interference. It is irrelevant whether a future observer might decide to acquire it. The mere possibility is enough. Do you want me to put that in the side chat for us? So what are you calling woo?
John, I would like to go to a different topic. I think this one's been.
Okay, let's go to this topic. Please provide scientific evidence of.
No, I want to get into something specific. Let's go to something specific, like you don't believe in gravity, right, John?
Believe.
Hey guys, I'm getting off this real quick before you get into the next topic. I got nothing to add.
All right, Ed.
Ed. Thanks for showing up, man.
I'll be in the chat.
All right, dude.
Later.
Gravity.
No, you say that gravity is not something real. You say it's all buoyancy and density, right, John?
I don't. No, I don't.
Oh, I thought that. I'm sorry then. I thought that was your position, that there was no such thing
You
as
didn't
gravity.
see my gravity presentation then.
No, I didn't. I thought I had a conversation with you about density and buoyancy. I thought I saw that in the. I thought I saw that in a discussion you were having in.
No,
in
you're
YouTube
just conjuring
videos.
that. I never.
Hold on, let me see if I. Hold on. Didn't you have that in George's video? The buoyancy density thing? No. Am I wrong about that? I could be wrong because I've had this with many other flat earthers. So
that's what you stereotype. That's all you guys do is stereotype fallacies. Let me ask you a question. I ran into a spinning ball guy the other day. He told me that ink molecules were alive. Do I need to explain why they're not to you?
That ink molecules were alive?
Yeah, a spinning baller told me that the other day.
Well, I don't know what that has to do with the spinning
apply
ball.
To you? Does that argument apply to you? Do I need to explain to you why they're not? That's what I'm talking about with stereotype fallacies. Since I'm a flat earther, I believe this. I don't. Why don't you ask me?
I think I just recall being in a hangout with you. I got to go look through the hangouts, but I recall being in a hangout with you where you told me that there's no gravity, that there's only buoyancy density.
I didn't say that. That was some other knucklehead. So back to your question, which gravity are you talking about? Einsteinian or Newtonian? Pick.
Well, they both the Einstein equations break down into Newtonian equations.
No, they don't. No, they don't. Einstein gravity is not a force. Newtonian gravity is a force. You got a big problem. They're not even in the same geometry. Right? Newtonian gravity is Euclidean 3 space. Einsteinian gravity is in pseudo-Riemannian 4 space. So which gravity, please?
Well, which one? I think you might have broke him, John.
I'm not trying to break him. He's trying to get around his scientific evidence for a spinning ball religion. All I want is the scientific evidence. Listen, if they think we're idiots, no problem. Go ahead and give me the scientific evidence. We'll go ahead and confirm and validate that it's a spinning ball, and then I can just stop doing this. I have no problem with it. Post the hypothesis. Of course, you don't know what one is. That's a problem, right? Sorry about this, Speck. It needed to be done.
No, you're good, man.
Interesting, and you guys are being somewhat decent to each other, so I'm open for it. I'm learning stuff too, so it's cool by me, man.
Yeah, but I think you broke him.
No, I didn't. That's not my. The breaking isn't the point. He's got claims. He told. What did he tell you? That you were coming on here and giving your points, and you wouldn't stick to any point about whether the Earth was flat or a sphere? Well, let's hear his evidence. I want to hear his evidence for a sphere. We already destroyed the spinning part. It's not spinning. Do we want to go over that?
Yeah, I'd like to hear what he has to offer. I mean, he seems so insistent upon his beliefs and so insistent upon making me believe as he believes. So I'm just curious what makes him believe as he does.
Well, of course, a scientific hypothesis only answers the how and the why questions. It's a cause and effect question. Of course, the spinning or the ball or flat is a what is question. You can't even fit it into the method.
Mm-hmm.
It's all bollocks. No one can scientifically validate it either way. So why are they saying that they have scientific evidence? Let's see it.
Yeah.
I want to see it. Give me the best proof of a spinning ball, please. I want the hypothesis.
But we've had pictures for 50 years.
Yeah, I got the gerbil on Mars.
Oh,
Let's
man.
go over that picture.
Yeah, that's a good one.
That's not science. That's just an observation. That's only the first step of the scientific method. Let's get the hypothesis and then experiment. Of course, your hypothesis is your experiment statement. So before you do the experiment, you have to have a hypothesis. And fifth grade is now released.
I'm sorry, I woke my daughter up with my yelling here. I forget where we were.
Sorry, are we back on gravity?
We can go back to gravity, yeah.
Okay, which gravity?
Oh, well, it's all the same gravity. The Newtonian equations for gravity, they still apply, and Einstein's equations do break down to the Newtonian equations.
Sure. Show us.
I could bring George in on another hangout since he has a PhD in mathematics, and we can go over how.
We already been with George.
But you stopped responding to his thread, so.
Well, I stopped
George,
responding
if I bring
because
George
I
in here, he
hammered
can
him.
show you how the Newtonian, because his PhD is actually on Newtonian.
I don't care what his PhD in. He couldn't even answer whether the damn Earth, the atmosphere, was spinning with the Earth or not. I mean, why would I ask him about gravity?
What do you mean? He answered you. Of course, it spins with the Earth. You made the argument. You made the argument to him.
Okay, wait a second. You're saying the atmosphere spins with the Earth?
Yes, but it doesn't spin lockstep, right? Listen. When I'm blending my smoothie in my blender, The liquid inside does not spin lockstep with the blades inside.
Well, the atmosphere is not a liquid.
The atmosphere is a fluid, and all the behavior is perfectly in line with fluid mechanics.
Yeah, no. Liquids and gases are kind of different.
Well, water is an incompressible fluid, but it's a fluid nonetheless.
Yes, that's right. But gases are compressible, right?
Sure, but that doesn't change the fact that
yes, it does.
Wait. How does it change the fact that? So you're telling me that the Earth is unable to drag. The only way that the Earth can move the atmosphere around is if the atmosphere is moving lockstep with the atmosphere.
I want you to show me. I want you to post the experiment where gases spin with a rotating solid body just 5 centimeters above the surface.
What do you mean? Like that you could do that with a propeller or with a can in a drill?
No. Really? Well, post the experiment then.
You don't think that you can levitate a sheet of paper over a spinning can with a drill?
I am saying that gases will not rotate in lockstep.
But nobody said they rotate in lockstep. Nobody said they rotate in lockstep.
It doesn't matter whether they spin in lockstep.
The gases are free to move around just the way that when my smoothie is blending in a circle, I can still stick my tamper in there and mess around with the flow in there while it's in circulation.
Gases aren't liquids.
Gases and liquids are fluids, and they behave according to the laws of fluid mechanics. Right?
Gases and liquids are not the same. What's the difference between a gas and a liquid? What's the biggest difference?
John, gases and fluids are both, gases and liquids are both fluids, okay?
Yeah.
And they both behave by the rules of fluid dynamics.
No, they do not behave the same.
Absolutely.
Why?
Well, there's the compressibility, but not all. But fluids, there are certain fluids that are more compressible than others as well.
Who cares? That has nothing to do with my question. What are the difference between gases and liquids? What's the biggest difference?
Go ahead, you tell me, John, because I don't know what answer you're looking for.
Because gases or liquids don't have intermolecular bonds. Do you understand that? That means they can't spin in lockstep. That means they'll increase in entropy, right? Very quickly. That means when I go to my tire and I push the valve, what happens? Gases go from high pressure to low pressure and increase their entropy, correct?
I'm sorry, what was the question?
And if you're talking about gases spinning with the Earth, then you have to explain the existence of east, south, and north winds. Floor is yours.
What's your question, John?
If gases spin with the Earth, then you have to explain east, south, and north winds.
But
That's the question.
If gases are free to move, depending on the force that's applied to them, what's preventing them from moving in multiple directions? They can be spinning with the Earth and have their own movement because they're moving. They're independent of the Earth, right? So in other words, by the way, I could do this test with a propeller blowing air one direction, and I can move it another direction as well.
Does it spin with the propeller?
Yeah, absolutely. That's how
really?
the propeller.
So how far away does it spin with the propeller? Does it spin like from here to like Colorado?
It spins quite. It creates a vortex, which actually in airplanes you have to apply rudder correction.
So
on
we're
takeoff
not talking about a vortex.
Because there's a vortex behind the propeller, because the air is spun around with the propeller.
Well, if there's a vortex,
dragged around with the propeller.
If there's a vortex, sir, then it's not spinning with the dang propeller, now is it?
No. But it's created by the propeller dragging it around.
It's not spinning with the propeller, though.
It's spinning at the propeller, at the surface of the propeller, just like
at the surface.
Yes. Absolutely. Like, for example, let me give you an example. Let me give you an example.
Is it the same gas molecule, sir?
What do you mean, if it's the same gas
molecule?
molecule?
Is it the same gas molecule? I'm talking about spinning in lockstep with it. It has to be the same. It can't be more gas molecules coming into the propeller, because that's a fallacy, right? It's a false equivalence fallacy or a false comparison.
Oh man, I wish I could keep this conversation going, John, but my wife is yelling at me here because my daughter is I keep raising my voice here and my daughter keeps waking up. So we'll have to continue this later, John. But
no problem.